Hi, so in this video, I'm going to look at whether or not sound waves can move objects. Well, first of all, we already know they can move objects, like this. So yeah, as you can see, moving objects with sound is not only possible, it can be quite fun, but we're talking there just about hair, which is very light and easy to move, but that can be moved with sound waves. But what about large objects? Is it possible to move large objects using sound waves? For example, the big blocks of stone that we used in the pyramids. Is it possible that sound waves were used in some way to move those? Well, obviously, I wasn't there, so I can't say yes or no whether sound waves were used to move those blocks. What I can do, though, is propose my theory on how technically sound waves could be used to move large objects. But first of all, before I show you my invention idea, I first have to talk about something called sonoluminescence. 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 Yeah, I've no idea how you pronounce it, but that thing. I'm going to show you a quick video about how it works.
It's a process called sonoluminescence.
The first time I saw sonoluminescence was in a darkened room. I was transfixed to look at this spherical flask of fluid. And you look into the center, and in the center see a glowing blue-purple light, which could be seen with the unaided eye. It looked like a star in the heavens.
Seth Putterman called it the star in a jar, a tiny spot of bright light contained in a flask of liquid. This star in a jar is made when a sound wave is passed through a small bubble inside a flask of liquid. And this sound wave makes the bubble do something remarkable. First it expands, then it collapses. And this collapse happens so violently that vapor molecules trapped inside the bubble slam together.
Okay, I'm going to stop that there because what I'm interested in there is not so much the bit where it collapses and creates the light and becomes like a mini star in a jar. And by the way, if you want to see that video, just look up "star in a jar," and I think you'll find it. Really interesting video about sonoluminescence. So it's the sonolumin. Yeah, you know what I'm talking about. That thing, right? I've derailed myself. Right, that's it. Yes. So I'm going to stop that there because I'm not really interested in the bit where it collapses and creates the light. All I'm interested in there is that when you first start to put the sound waves through that little bubble that's trapped in the water, it expands before it gets to the level where it collapses. So if you just put the amount of energy of sound wave into the bubble just to make it expand, that's the bit I'm interested in, because with that, I think I've figured out a way to move large, heavy objects. Okay, so time for me to get into my invention. I'll do that now. Okay, so imagine what we have here is like a container. This could be metal or plastic, something strong. Let's go with metal. And so it's got these different compartments here. And just imagine this is full up with some kind of fluid or oil, something like that. Okay, so there's like a 3D sort of depiction of it. There's a sideways cut through. And the next thing to imagine is, if you imagine this little yellow thing here is a small bubble. What we want to create is that star in a jar. So what it would actually be is like a small, very small sort of balloon or rubber ball or something like that. So it's got some kind of membrane, some kind of outer shell, like a sphere, that is flexible. So maybe rubber, something latex, something like that, filled with either air or some kind of gas, which would react to sound waves. So the red ball would depict the exact same thing, but if a sound wave is put through it, it would expand. You know, as per that video, the sonoluminescence. If just enough energy is put through just to make it do that first part where it expands before it collapses in on itself, this is what you would get. So a tiny kind of rubber ball, say, filled with gas or air, and when you put the sound wave through it, you do it to the level where it just expands, like a balloon, just getting inflated slightly, goes a bit bigger. Okay, so that's the first part. Next, what we want to do is make lots and lots of them, loads of them, thousands of them, these tiny little spheres that are able to expand. So we want to fill up our container with this fluid, which has thousands of these things all within it. The next thing is we need to coat this container in some kind of rubber, and it needs to be glued, affixed to all of the surfaces along the top. So all of these black lines here depicted would be a point where it's glued down, stuck on. So if I zoom in here, I've used like a purple color for the top layer here, just to depict like a layer of sort of rubber, something that's strong but can expand. So the next part of this kind of invention and experiment would be to put sound waves targeting just that first compartment on the left here. So what we have is a contained compartment of fluid with thousands of these little spherical bubbles in them. So if we put the sound waves through that first area, that first container, it's going to expand. And it's got nowhere to go. The fluid has nowhere to go. So it would push upwards, creating a bulge in the rubber like this. So hopefully my little 3D drawing here is clear enough to show what would happen. And so then either the audio device itself would move along, or you could have lots of them and you would just switch one off and the next one on, and then you would get the next compartment expanding. So it moves along. So this one goes down, this one goes up. And you do the same thing along the line. Bang, 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 bang. So what that does is it creates a kind of a ripple, a wave going along the surface of this device, the rubbery top. Expands, expands, expands. It goes along in sequence, so it creates like a wave. And you could do this several times in quick succession, making a kind of a ripple, a wave. You could even have several waves going at the same time, like maybe area 1, and then by the time that gets to area 3, area 1 starts again, so it's like several waves. You get the point. You can use the sound waves to convert that sound into kinetic energy, because it's making an expansion, it's making movement. You can manipulate that to create this ripple effect down this kind of device. This is just on a small scale. Now imagine this on a massive scale. If it works, then you could put this kind of thing like a big long board underneath, say, a heavy object. You could sort of roll or move a heavy object onto it, and then technically, like a big conveyor belt, use your sound waves to blast this thing along, ripple it along, and move it along the surface that you want it to move. So that's the basics of this sort of invention, this idea I thought about of a potential experiment and how to move objects with sound waves. Now, is it practical? Probably not. Is anybody ever going to make this? Probably not. But just in terms of theoretics and a theory of physics, I think this would work. I genuinely think that this, if we created such a thing, use the sound waves in such a way. Now, would it be energy efficient? I don't know. I don't know how much energy in terms of sound waves you'd have to put into this thing to get it to move objects, or whether it would really be viable, feasible, worth doing. I don't know. That's not really what I'm interested in here. It's just the question I wanted to look at is, can sound waves be used to move large objects? So you scale this up large enough, I think yes. Whether those big blocks of stone would actually move, I don't know. Maybe, maybe not. All I do know is hydraulics is very strong. I know from my forklift days and things to do with machinery about how much pressure and just how strong hydraulics can be. Because when you've got the fluid that can't really expand and you put something in there that is pushing out, exerting force, you can create tremendous forces. When I first thought about this, I thought about, what about if you already had a block of stone on the floor? What would you do? Could you pour this kind of fluid underneath it and kind of use like capillary reaction for it to seep underneath? And then if you sort of like block around the edges with clay or something, could you then use the sound waves to sort of get it shifting and moving? Probably not. I think that would just spring a leak. I think that would just shoot liquid everywhere or fire something into the air. I don't know. But if it's contained within this kind of structure, this kind of, let me get it back up on screen. This sort of container type structure that looks like this when it's open before it's fixed in. You would get to have a great. What is going on with my screen? There you go. You'd have much greater control then over which bits are expanding and where you're moving the sound waves and things like that. So I think technically you could make here a sound wave conveyor belt. Who knows what the real world applications of that could be? If it worked, if it was efficient, could it have applications in airports for moving luggage around? Could it have applications in warehouses for moving products around? Now, those kind of places already have things in place, but I don't know how much energy do they use. In the long term, would this use less energy? I don't know. Would there be less energy lost? Because at the moment, you've got electric motors turning things, you've got friction and heat and wasted energy that way. This might be a more efficient way. I don't know. I'd love to know your thoughts. Anybody out there, whether you're into physics or not, or if you're into product design, do you think this could work? Do you know any students working at universities that could maybe work on making a small prototype of this? If so, hey, maybe show them this video. I'm quite happy for them to just take this idea and run with it. All I'm doing is just thinking out loud. So that's it, yeah. Can we move large objects with sound waves? I think it's possible. I think I've invented a device to do it, but can I make that device? No, not me, but maybe somebody out there can. That's it for today. Hope you enjoyed the video, and I'll see you all later. Bye.